Good morning. I'm honoured to be here in Bangalore today talking to you all. So, talking to such a huge room full of software developers. Now, I know that we're all supposedly developers or engineers, but sometimes it can seem like we're working in the fashion industry with the pace of change that we have to cope with. One of the latest trends or fashions that you might have heard about is serverless computing. And I aim to start my talk by trying to convince you that serverless is part of a more fundamental change that's happening in our industry at the moment rather than the latest trend, rather than the latest fashion trend. And I'm going to do that by going back to... Oh, hang on. No, I'm not. Bear with me. This does not seem to be working. Where's that gone? Apologies. Let's do it this way instead. Okay, I want to do it by going back to the days when computers looked like this, programmers looked like this, and programs looked like this. This is what one of the first apps looked like. I love this. You can see written on the side here the subroutines or the dependencies, if you like, of this program. This top bit here is the actual code, and they've drawn a big fat line down the side of the deck so that when they drop it in their rush to get it in the machine, they can get it back in roughly the right order. This is the first app, the original app. And the way that you used to run an app is you used to stand in line in a corridor somewhere, waiting for your turn on the machine room. You used to hand your app to the computer operator, and they would put it in the computer, and it would run. It would take the whole use of the machine until the app crashed or it gave you some useful output. So we can think of it like this. There's just the app and the machine. This was pretty inconvenient for a number of reasons. So the good developers and the good operators started to build tools on top of the machine. This abstracted some of the things away from the concerns of the developer. So things like hardware interfaces, things like job control were written originally as libraries that an app developer could import into their program to give them some of the functionality. This in turn allowed more complex and more capable programs to be written, apps to be delivered. And what we found over time is that those apps consolidated into what we know today as the operating system or the operating system kernel. And again, this provided more capabilities to the app. We got more complicated, more capable apps that were capable of delivering more benefit to the users of these apps or programs. Now, at the same time, we observed that, and we observe this in general actually, when you give someone a new tool, it will change the way they work by its very nature. So we've given programmers, app developers, new tools here in these libraries and these operating systems, and this has caused them to reflect about the way they work, and we saw the emergence of the discipline of software engineering at around the time that the operating system emerged. Now, the point I want to make with this is that this pattern here of new technologies and tools emerging, consolidating, and commoditizing is a pattern that we can see repeated throughout in a cyclic way throughout the history of our craft, of our discipline. So, next up, we developed some tools on top of the operating system. Libraries. This became the user land that we know of today. A distribution in Linux speak and in Windows, for Windows folks, quite often distribution and operating system are one and the same and referred to as an operating system. So now your app was dealing with libraries, other dependencies, rather than having to deal with the operating system directly. We're probably, by this point, we're probably like 1980s, early 1990s, we're in the throngs of client-server computing. And we're starting to see lightweight methodologies emerge in reaction to some of the heavyweight software engineering disciplines that have preceded it. So Agile, DSDM, and the like. It's around this time that this happened. Our apps grew so big and so complicated, and our audience grew bigger, that one machine was no longer enough to run our apps. So we had to we had to devise a way to run our apps across multiple machines, sometimes a couple, sometimes hundreds, depending on the app that we were interested in. And the pattern repeats itself. We built some tools to help us deal with this distributed computing system. These consolidated into what we call the cloud today, starting in around 2007. And this, again, as it did in the past, enabled a new set of apps to be written that weren't possible before. Now, it'll be no surprise to you, you probably guessed where I'm going with this now, right? So we're now in a state where we have a mature cloud ecosystem. We have an established and commoditized marketplace, certainly in the infrastructure as a service space. And we're starting to see tools emerge on top of this to help us manage the complexity of the clouds. I want to highlight a point that Venkat made earlier. There's two types of complexity. There's an inherent complexity and there's an accidental complexity. I think it's really important to note that someone's inherent complexity will be somebody else's accidental complexity. So if, as someone who has been on the end of a pager operating a cloud for many years of my life, the inherent complexity in the infrastructure domain is my inherent complexity. But for the person writing the app and wanting to deliver services to the user, that's accidental complexity. They don't care about that. So one person's accidental complexity can be another person's inherent complexity. So here we are today. I think this is roughly where we are today. We're seeing a bunch of tools, things like Kubernetes, that are being built on top of the infrastructure as a cloud to help us manage some of these cloud scale issues. And my argument, my pitch to you today, this morning, is that the serverless movement is going to be the consolidation and commoditization of these tools into something that is more widely understood and more widely useful. Okay, so we might be able to have a stab at a definition of what is serverless at this point. If I was a marketing person, I would probably write something like the next frontier for modern app development, which, whilst I believe to be true, is not particularly useful. Or we could say that it's a category of cloud services that raises the abstraction level so that developers, specifically app developers, never think about servers, VMs, or other IaaS concepts. Or for me, it's all about the code. It's all about the app developer's code, specifically. Okay, let's go into a little bit of detail about some of the tools that I think are going to form part of this, this next layer of abstraction for us. The beating heart of any kind of serverless architecture or serverless platform is a functions as a service. This is you can think of it as roughly analogous to the compute in the infrastructure layer. It takes your code, it will, provides you with some way of invoking it. Normally that's an HTTP endpoint, or it could be consumed off the end of a queue, for example. The important thing is that you're giving your code to the functions as a service platform. You're not dealing with any kind of images or anything else. The functions as a service platform then takes care of all of the infrastructure concerns for you. It deals with provisioning the machines, hooking them up to the right networks, making sure that security patches are rolled through as and when you need them, making sure that enough hardware is available to service the requests for your audience so it will scale up, and importantly, it will scale back when your traffic declines. It will deal with all of those infrastructure issues, which today, in the DevOps way of working, is very firmly in the domain of the application developer. But a functions as a service is not enough on its own. You also need somewhere to store state, because a function is just a small piece of code that takes an input and gives an output. You need somewhere to put state. Oracle knows a thing or two about that, I'm told. But the other thing that you need is a way to stitch all these functions together. So if you've split your app up into lots of smaller pieces, which is a fantastic idea, by the way, because for many reasons, the small pieces are much easier to reason about. From a security standpoint, it's fantastic because you can make sure that that piece of code only has access to the secrets and credentials that it needs, so you can very tightly limit the blast radius of any potential vulnerability. But now, so now you split your app up into all these different functions. You need a way to stitch that back together into a coherent whole, and this is what I mean by workflow. This is what I mean by workflow. The other thing that serverless is changing is the economic model of computing, because one of the key points about serverless is you only pay for what you use. It really is truly pay-as-you-go computing. So in a functions as a service platform, you will be billed per millisecond or per 100 milliseconds for the RAM that you are consuming. Now, I think it is this that has the potential to free us from our dependency, if you like, get us into dependency rehab. Part of how we've ended up in this place that Venkat outlined in the upfront talk is that it's so easy to add dependencies, super easy to add dependencies. There's no cost to adding a new dependency, really, particularly as everything it tends to be open source or free at the point of consumption today. In the serverless world, there will be a real cost to not being disciplined with your dependencies. There will be a real visible financial cost to not being disciplined about your dependencies. So you will have to understand deeply how your dependencies work and how that's going to affect the runtime execution of your program. I think it's this that's going to change the way we engineer software more than anything else. Okay, I want to introduce now the FN project. So the FN project is an open source serverless platform. We open sourced it in October last year, so it's still fairly young. This is a platform that you can use to build a set of serverless services, if you like. Today we're focusing on the FAS and the workflow aspects of the serverless platform that I outlined earlier on. Why did we choose open source? That seems a strange move for Oracle to do new development open source. So there are a couple of reasons for that. First of all, we didn't think the market could tolerate another proprietary closed source functions platform. But mostly, we think it's really important to offer an awesome local development experience. You still do the majority of your work sat in front of your laptop. And if you have to round trip to the cloud every time that you make a change, that's going to slow down your local feedback loop. By being open source, that lets you have the exact same code running on your local laptop that will be running in the cloud service. And so you can have a really tight, really awesome, optimized local development loop. It's got awesome Java support, obviously. We are the Java company, after all. We've introduced the concept of an FDK, which is a function development kit. That's a small library that you can import into your code, and that will help you out with things like getting configuration into your functions, with marshalling input and output into the objects that your favorite language knows and loves. So we have first-class FDKs for Java, obviously, for Node.js, Python, Ruby, and Go. Go, of course, yes. Speaking of being a fashion-driven industry. In the Java FDK, we also ship a JUnit rule so that you can get a really high degree of confidence that your function is going to behave as you intend it before you even ship it to the cloud. And this is a key differentiator for us. We are what we call a container native or a container first FAS, in that all of our functions are under the hood, in fact, Docker containers. And if you need the flexibility beyond what we offer in the platform, you can ship any Docker container and have it run as a function. So this lets us support a whole raft of languages, of other languages, very easily. We think this is great for our users because it uncouples them from the life cycle of the cloud provider. You can run whichever version you need. You don't have to wait for support from your cloud provider. The other thing that we have in the FN project is an experimental service we're calling FN Flow. And this is our take on the workflow problem of how you stitch functions back together again to form a coherent application and user journeys. Now, other clouds, our competitors, seem to have adopted a state machine model for this, which works for a certain class of problems, but tends to explode in complexity when you start to have to handle error cases and edge cases. You get a lot of different states. We think that a promises or a futures way of chaining these functions together is a much more natural way of programming, and this is what our FN Flow system is all about. I don't have enough time to go into any more depth today, but I'm going to be hanging out at the booth at the back there all day if you're more interested in finding out more about that. Okay, what I'm going to, a very quick demo, I'm going to show you the Hello World experience of the FN project. That's really tiny. Huh. Okay. I guess we'll just have to go with it. Can folks kind of see that? I can make it a bit bigger. I don't know why my machine is misbehaving. So what I have here is a new Linux machine. It has the FN CLI installed from our GitHub repository, and it has Docker installed. They're the only prerequisites. I can start a local development server by issuing the FN start command, and the D flag just means that it's going to start in the background. I'm going to make a new folder to put our new app in. I'm going to change to that folder, and I'm going to init a new function. And I'm going to say runtime is Java. So when I do an init, I specify a runtime, and the FN project is going to generate a sample function for you, which contains a bit of boilerplate. As you can see, it just generates a hello world function and a hello test and a test for that function. I can then deploy this function to my local development server with the FN deploy, and this will go ahead and build the function and deploy it to the development server. It's actually, you may have noticed a POM there, so it's using Maven to do the build, or is that Maven using me? I'm not quite sure. And then I can call the function with the FN call command, and we get hello world. So what I wanted to do, I'm kind of out of time now. I wanted to show you some of the code. The point that I was going to make, though, is that it's just Java. There is nothing unusual about this code. You're not having to import any libraries, learn any new SDKs. This is just the Java that your grandmother wrote. With that, I'm out of time. I'm going to be hanging out at the booth all day today. If you've got any more questions or you want to see any more in-depth demos, you can check out the project at fnproject.io. I'm ThomLeggett on Twitter. Thank you very much for listening.